Example number 13. Calculate the pH of the solution after adding 10 milliliters of 0.1 molar HCl to 20 milliliters of 0.1 molar NH3. The Kb of NH3 is 1.8 times 10 to the minus 5. First of all, let's determine our equivalence point, or the volume to the equivalence point. So we would have to add 20 milliliters of HCl using MAVA equals MBVB to reach the equivalence point. If I've only added 10 milliliters, that's before the equivalence point, and I'm in zone 2, just like the previous example. So let's set up our neutralization. So we start with 0.002 moles of base, and just to be clear, that comes from the concentration of the base, 0.1 molar, times the volume, 0.02 liters. Okay, that's moles of base, plus the moles of the acid, so 0.1 molar times the volume, 0.010 liters, gives me 0.001 moles of acid. Since we're before the equivalence point, we will neutralize all of that acid. So we end up with 0 moles of HCl, 0.001 moles of NH3. And in doing so, we generate this NH4, the conjugate acid of NH3, NH4 plus 0.001 moles. So I can find the volume of the NH3 dividing by the total number of liters. So 20 plus 10 is 30 milliliters, or 0.030. So you have 0.033 molar NH3. And I do the same thing here. This is divided by 0.030 liters, and we get 0.033 molar conjugate base. So we use Henderson-Hasselbalch because we have a buffer situation happening here to find the pH. But the pH using Henderson-Hasselbalch is the minus log of the Ka, and we were given the Kb for ammonia. So we need to find the Ka. It's 1 times 10 to the minus 14 over the Kb. We get 5.56 times 10 to the minus 10. So sub that into Henderson-Hasselbalch here, plus the log of the base over the acid concentration, and we get a pH of 9.29. And we would expect the pH to still be pretty basic if we're before the equivalence point.